Hello, today we're going to be working with the benzoin condensation. So in the synthetic route, we are actually in chapter 48. This is the reaction scheme of the benzoin condensation. As you can notice, there's going to be one benzene skeleton and our molecule is going to form a 2 benzene skeleton molecule. So it is important to know this when you do your calculations. Traditional approaches involve the cyanide ion as a catalyst. The cyanide mechanism is outlined in detail in your book. Yet, cyanide is highly toxic and not used in our organic chemistry teaching labs. We will be using something that's more natural, the thiamine hydrochloride or vitamin B1, as an alternative catalyst. This is the reaction mechanism. So thiamine exists as a salt, and the X- anion can vary. We will use the chloride in this case, thiamine hydrochloride. So in the first step, we're going to have a basic hydroxyl ion that is going to remove one of the protons from the thiamine hydrochloride, and it's going to form this pseudo ion species that is shown in the right. So we're going to minimize the complexity of the molecule by turning R1, the blue section of the molecule, and R2, the green molecule, since we're just interested in this heterocyclic atom. So we're going to have this pseudo ion, as we've mentioned before, the negative charge on the carbon and the positive charge on the nitrogen. The negative charge is going to attack the carbonyl of benzaldehyde, and it's going to incorporate the benzaldehyde molecule into the skeleton of the catalyst. That way, we're going to form this species that has a positive charge on the amine, and the negative charge is going to be transferred into the oxygen. The oxygen is then going to be protonated by effects of water, and we're going to have the corresponding alcohol and a positive charge on the amine. So then another hydroxyl group is going to remove one of the protons, and we're going to regenerate the negative charge in order to make, yet again, another sweeter ion molecule. This time the negative charge is on the benzaldehyde carbon. So here in the bottom, we show the resonance structure that we're going to be using and the most stabilized structure of the molecule. So the double bond is going to actually migrate into the benzoin junction with the catalyst, and that way there's a more stable resonance contribution. Yet in this interchange, there's going to be this negative charge that is going to attack yet another benzoin skeleton and is going to transfer the negative charge to the oxygen. Therefore, we have a three skeleton species that will have 2 benzoins and the catalyst. And the negative charge is going to be transferred into the oxygen of the second benzoin. This second anion is going to remove the proton from its neighbor oxygen, and that way we're going to form the corresponding alcohol. We're going to form a ketone, and by effect of that, the catalyst is going to be expelled and it's going to be regenerated into the sweeter ion molecule that's shown in red towards the end. Catalyst means that this molecule is prone to another attack, so we can use less equivalence of the catalyst to make many reactions. For the experimental procedure, we're going to do the following. We're going to add 1.04 grams of thiamine hydrochloride. We're going to add 3 ml of water, and we're going to wait for the whole system to be completely dissolved. Make sure to use a 50 ml Erlenmeyer flask. We're going to add 8 ml of ethanol. It says 95%, and that's how it's sold. We're going to add 3 ml of aqueous 10% NaOH solution, and then we're going to add 3 ml of benzaldehyde. We're going to mix thoroughly after each addition. We're going to keep it at room temperature for overnight. So the synthesis is actually going to be completed until your next class meet. By the next time you see your container, you should have a mass of fine crystals. We're going to filter using a small Buchner funnel. The Buch procedure calls for the Hirsch funnel, which is not available. So we're going to recognize the difference between the funnels. The Buchner funnel is actually made for vacuum filtration, while the Hirsch funnel is just made for gravity filtration. So in some cases, the benzoin may not crystallize and may develop as an oil. So in order to facilitate the crystallization, we're going to place your flask in an ice bath. We're going to gently scratch the inside of the flask with a glass rod or a metal spatula. If necessary, we're going to place a tiny crystal of benzoin that we're going to be providing to you into your flask and swirl and cool. This will actually make the nucleation procedure, and it's going to induce the precipitation of your compound. We're going to wash your product with small volumes, around 7 ml of cold, 50% ethanol, 50% water, and then only with cold water. The benzoin will dissolve in ethanol, but it's less soluble in water. So make sure your ethanol solution is no more than 50% and cold. We're going to dry the compound and weigh the actual yield. Finally, we're going to make IR and proton NMR spectroscopy.